So the next principle of GPS is position calculation. So if there is 4 satellite, we can exactly locate the position of any point on Earth's surface. Okay, so we can discuss it. So for unknowns to be determined, their position coordinates x, y, z and time of travel of signal. So these are the 4 unknowns which has to be determined. And observation of 4 satellites produce 4 equations. So we can have observations from 4 satellites and it will produce 4 equations. And when receiver picks up a signal from one satellite, the position will be an imaginary sphere with satellite as center and distance as radius. That is, in this figure, if the receiver, if the object is seen by single satellite, this is the case. Okay, so if this is the point on Earth's surface, the distance from this point to the satellite will be the radius of this circle. Okay, so you remember this figure, that is, the Earth's surface feature is viewed by only single satellite. And if the receiver picks up a signal from single satellite, the position will be an imaginary sphere with satellite as center, imaginary sphere with the satellite as the center and distance as radius, and the distance between these 2 points is the radius of this imaginary circle. So that is the case when the point is viewed by a single satellite. Okay, so the point may be anywhere on this imaginary surface. And next, the GPS receiver starts picking up signals from 2 satellites. That is, this is the case, that is, if the point is captured by 2 satellites, the position of GPS receiver will be done of the 2 points of intersection of 2 large circles. So the position of GPS receiver will be one of the 2 points of these 2 intersection points. That is, if the point is viewed from 2 satellites, there are 2 imaginary circles created, and so there is 2 points of intersection. Okay, so the point may be any of these 2 points. This is one point of intersection, this is another point of intersection. So the position of GPS receiver will be one of the 2 points of intersection of the 2 large circles. That is the case where when the point is observed by 2 satellites. Okay, so here there are number of points and here the point is reduced as 2. So from any of these 2, that will be the GPS receiver. And next case, when receiver picks up signals from third satellite, that is, when the signals are picked by 3 satellites, the position of the receiver will be on point of intersection of these 3 circles. Okay, so here the position of GPS satellite will be the intersection of these 3 satellites. That is the case if it is viewed by 3 satellites. Okay, and last, with 4 satellites, the receiver will get a precise position. That is the case here. That is, if the point is viewed by 4 satellites, we will obtain the exact precise position of that point. Okay, we will get a precise position and it will be able to compute the elevation of position with respect to a selected data. So in that case, we can also calculate the elevation of that point from the reference, from the selected reference data. Okay, so this is the position calculation, and I will repeat again, that is, if the position is located by single satellite, it will be an imaginary circle, and the distance from the GPS receiver will be the radius of that imaginary circle. And if it is viewed by 2 satellites, there will be 2 imaginary circles and the intersection point, 2 intersection point will be created, and any of these point will be the GPS receiver point. And if it is viewed by 3 satellites, the GPS receiver point will be any of these 2 intersection point. It will be some more accurate than that viewed by 2 satellites. And if it is viewed by 4 satellites, we will get exact precise position of the point, and it is the intersection of these 4 circles, and we can also obtain the altitude or elevation of that point from a reference data. Okay, so like that we are locating the position of points on Earth's surface. Next, GPS measurement techniques. That is, 4 types of signal measurement approaches have been used for positioning with GPS. and important observable are chord and phase values. That is, important observable parameters are chord and phase values, and the methods are based on these two. These two are very important method for calculating GPS measurement. They are chord measurements and carrier phase measurements. First one, carrier phase measurement. Here the GPS receiver which record carrier phase measures the fraction of one wavelength, that is fraction of 19 centimeter for L1 carrier. When receiver first logs into the satellite and continuously measure the carrier phase from that time. Okay. So next is the number of cycles between the satellite and receiver in initial startup and the measured carrier phase together represent the satellite receiver range. That is, the number of cycles between the satellite and receiver at initial startup and the measured carrier phase together represent the satellite receiver range. So like that it is locating the position. Next is chord phase measurement. Here a GPS receiver determines the travel time of a signal from a satellite by comparing the pseudo-random chord it is generating with an identical chord in the signal from the satellite, and the receiver slides its chord later and later in time until it synchronizes up with the satellite's chord, and the amount it has to slide the chord is equal to signal's travel time. And the chord measurements are the difference in time between when the code is transmitted from a satellite and received at a GPS receiver multiplied by the speed of the light. So that is a process done in chord phase measurement. Okay, so these are the different techniques for GPS measurement. So this is the position calculation. Okay. So up to this GPS working principle is over. So in the next class I will explain the errors. Thank you.